friends, it's Caitlyn with Kaleideum, and today for this Kaleideum at Home, we are going to be talking about hurricanes. Now, I am a meteorologist, which means I study the weather and the climate. And since I live in North Carolina now, I love to teach people about hurricanes and tropical storms and how they can impact even us here in the Triad. If you didn't know, June 1st is actually the start of hurricane season. And we already saw a tropical storm start on May 18th that moved by the East Coast and even grazed by North Carolina. Now, some may think that's really early, but it's actually not very rare. Sometimes we do get tropical systems that start to form early in the season. But June 1st is the official start of hurricane season. So today, we are going to go over the basics of hurricanes and do a little activity for you at home. So let's go over the basics of hurricanes. Up first, we need to talk about how hurricanes form. Now, a hurricane is a very large, powerful storm that forms over an ocean, in our case, the Atlantic Ocean. Now, hurricanes can be as large as 600 miles wide. That's huge, and it can last for days and sometimes even weeks and causes terrible damage along our coastal areas. So hurricanes are generally called tropical cyclones because the name changes depending on which ocean that it begins in or forms in. So if you live near the Western Pacific Ocean, these storms are actually called typhoons. If you live near the Indian Ocean, these storms are just called cyclones. And if you live down under in Australia, these storms are called Willy Willies, which is super fun. But all of them, regardless of the name, is a hurricane or a tropical cyclone. And it's still a massive storm that forms over the ocean. But how do hurricanes really form? If you've ever baked a cake, or maybe even some cookies, you probably know that you need precise measurements, exact measurements of ingredients to actually make your cookies or your cake come out perfectly. The same goes for a hurricane or any kind of storm for that matter. You need a lot of ingredients to all match up to make a perfect storm or a perfect cake. So let's go over those ingredients now. First, we need a moisture source. Like I was saying, a hurricane is a storm that forms over an ocean. Oceans provide a lot of moisture, a lot of humidity in the air to create that storm. Hurricanes do not like dry air. They will actually make them be weaker. So we need a lot of moisture, so that's where our oceans come into play. Second, our ocean temperature actually has to be over 80 degrees in order for really big storms to occur. It can be under 80 degrees, but the biggest, most aggressive storms that we have form in ocean temperatures above 80 degrees Fahrenheit, which is pretty warm, feels like bath water. Third, we have the Coriolis effect or spin. So you've probably seen a picture or a storm or a loop of how hurricanes spin within their environment. So when we think about our Earth here, I have this globe, our Earth is constantly spinning, right? And it spins from west to east. So we're going around, here's North America here, that's where we live. It's going around from west to east. It's constantly spinning at a constant speed so we don't feel it. And it's also round, right? So our equator is actually going to be larger than our northern pole. So it's a little bit wider. And as we spin, the equator is actually going faster than we are up here at the North Pole. So if I were to put my finger here and here about the same latitude on this stripe and move it around, you can see that I only moved about this much up here, but I moved this much down at the equator. So the equator is actually moving faster than we are at the poles. And because of that, there is more spin. That's where the Coriolis spin or the Coriolis force comes into play. That is our spinning force. And because of that, we often see, here's North America again, we often see the hurricanes form right along the equator, coming off of storms that come off of Africa and come through the Atlantic Ocean when it's warm and move up the eastern coast. And because of that, we have this area, that Coriolis near the equator, that the spin is actually the strongest, so it helps these storms start to spin. Now, us in the northern hemisphere, that Coriolis is going to help to deflect things to the right. So our storms, our hurricanes, are actually going to spin counterclockwise, so the opposite way of a clock. In the southern hemisphere, though, if you have a hurricane, it's going to spin clockwise, or the same way as a clock. So that's kind of a fascinating fact there for us. All of our storms are going to spin, our hurricanes are going to spin counterclockwise. So look for that in the next time you see a picture of a hurricane or maybe even an animation of one. So now that we know our first three are a moisture source, our oceans, ocean temperature is greater than 80 degrees Fahrenheit, and a spin or Coriolis force, we have our fourth item. Now, our fourth item we're going to talk about is wind. Whenever you think about hurricanes, you usually think about wind, right? So we have something in our atmosphere called wind shear, which is the change in wind speed and direction with height. So if you think of our atmosphere as layers, each of those layers can have a different wind speed and a different wind direction. Now, when we have really big changes in wind speed and direction, hurricanes don't like that. They try to be stacked. So if you think of those Jenga blocks that you can get that game, you can stack them and they stay perfectly aligned, right? And nothing moves, it doesn't wobble, it doesn't fall over. That's how hurricanes like to be over the ocean. They like to be perfectly stacked. So they don't want winds coming in at different directions throughout its amazing structure from the surface all the way up to our troposphere. It actually wants all the wind to be in one direction so it can continue to spin and continue to keep its strength. And when you see different wind shear, you actually can look at the eye of the hurricane, the middle center part, and you can actually see it wobble. And that's not a good thing for a strong hurricane. It might be a good thing for us as it weakens, but you want to look for wind shear. That is an important factor, kind of a tricky one to think about, but you want it to have the same type of wind flow in one direction with height. So we want little wind shear. So our fifth item is just storms or convection. We want some source of storms or convection to happen first to be able to grow or to develop into a hurricane. So now that we know the five kind of ingredients for our hurricane, we need an ocean, a moisture source, temperatures above 80 degrees Fahrenheit, spin, wind in one direction, so little wind shear, and then some storms to develop. Those are 5 ingredients that we need in order for a hurricane to form. Now that you know the ingredients of how a hurricane forms, let's do the experiment and learn a little bit more about what a hurricane looks like. Now that you learned a little bit about hurricanes and how they form, let's make one of our own. All you need for this experiment is a bowl, preferably one with a light interior like this one. Some food coloring. I chose blue just because the water does look blue out in the ocean. I chose a butter knife for a stir stick, as well as some cool water. So our first step is going to be to fill our bowl with water. Now I chose cool water just because of the way it reacts with the food coloring, but in our oceans, it would be over 80 degrees when we would get these big hurricanes. And also our first ingredient for a hurricane to form is a moisture source. So that's why we have our water. Now you can take your stirring stick, in this case my butter knife, and we are going to move the water counterclockwise. Remember, in the northern hemisphere, our storms and our hurricanes are going to move counterclockwise. So we're just going to gently stir it, making almost a funnel on the inside. So we want to cause that spin to happen, because remember, that is one of our ingredients for our hurricanes to form. So we have that moisture source, we have that spin, and once we really got things going in the ocean here, let's uncap our dye and just drop one little drop in the middle and see what happens. You can already see it's starting to move around, and there it is. That is our hurricane that we just made. Now this looks very similar to our hurricanes that we actually see in our ocean. And you notice all of these bands on the outside, and it's moving super fast on the inside. These bands are the rain bands, and they're the arms of the hurricane. And that actually shows us that wind is coming in this way and wrapping inside and around that eye and upwards into our atmosphere. That's what makes these storms so strong and vertically stacked. Remember, we need winds that are just flowing in one direction, and we don't want a lot of change in wind speed and direction with height. We want very little wind shear. Now, as we start to watch this, notice how it starts to unwind. We're still moving counterclockwise, but you see the flow is kind of wobbly now, right? And we can see that in normal hurricanes as well as they move over land.
Land has a lot of dry air, and hurricanes cannot stand that dry air. It actually makes them weak and it starts to wobble. If you ever look at an eye of a hurricane and it starts to look kind of wobbly and wonky, that's because dry air and the conditions in the atmosphere are not as favorable for it to stay perfectly stacked and perfectly strong. So that is good news for us on the coast. When it reaches land, it really starts to weaken because of that dry air. And also our wind shear starts to increase. We get more wind change in direction and speed with height, and that also starts it to make a little less strong structure, and it weakens it a lot. So now that you know a little bit more about hurricanes and you've made a hurricane of your own, let's talk about hurricane preparedness and how you and your family can be prepared.
Well, I hope you had fun making your very own hurricane and learned about how hurricanes form in the Atlantic Ocean. But now let's talk about hurricane preparedness. Now, even though we live in the Triad and not right on the ocean, we still can be impacted by floods as well as some severe storms, damaging wind that could cause trees to fall, and things like that. So we really want to make sure that we are staying safe when a hurricane passes through. Flooding is one of the biggest issues we have with a hurricane here in the Triad. We want to make sure that our houses aren't in flood-prone areas, and if they are, to know how to get out of your house and go to a safe area, preferably one that's on higher ground. Now, wind and storms. It's actually known that hurricanes can cause some tornadoes outside of its main circulation. So we do have to watch out for that and listen to local officials and the National Weather Service to get those alerts, and you can even get them on your cell phone to make sure you and your family are staying safe. You can head on over to our Kaleideum At Home site. I wrote a blog all about the lingo of hurricane watches and warnings, and if you have family members on the coast, send them our link and they can learn how to be more prepared for this 2020 hurricane season. Thank you all for watching. Again, I'm Caitlyn with Kaleideum, and I hope to see you all very soon.